Okay, welcome to this math lesson. So first of all, subscribe and share this video with someone who might find it just as useful as you do. So today we are going to talk about the nature of the roots. And first of all, we need to explain what roots are. So roots are just the x-intercepts of a quadratic function. Like this one here is a root, and this is also a root. But this function has no root because it does not cross the x-axis. Okay, so because we are looking for roots, what is a better way to find those roots than to use the quadratic formula? And there is none. So we are going to use the quadratic formula to determine the roots. But the nature of the roots is kind of the properties of those roots, like what they are like, and it is all defined by this triangle right here. It is called the discriminant of a function. So the discriminant of a function is just equal to b squared minus 4ac, and this is kind of familiar because it is just this part right here from the quadratic function, and that's really much what nature of roots are. So say you are in a process of finding the nature of roots, and for some reason you find that this discriminant is let's say it's less than a 0, which means that the discriminant is just a negative number. What do you think will happen? So from the quadratic formula, let's say x is equals to, and then the value of negative b, let's say it's 5, and then we say plus or minus the square root of. In here you have to put in the discriminant because this part is that one and it's called the discriminant. So yeah, you have to put in the discriminant in there. And let's say this number is a negative according to what we're saying right here, and you know that a square root of a negative number is not defined. The number you're gonna get here is non-real, so the nature of the roots are non-real, so they are non-existent. It's kind of this function, it has no roots, like it has no roots because it does not cross the axis. I hope that makes sense. And if you compute the discriminant and find that it is greater than 0, which means that the discriminant is a positive number, you're gonna put a positive number right here, and then the square root of a positive number is defined like it's a real number. So what you're gonna find out is that the roots will be real, like it's a defined number. The roots is real, and that a real number can be rational or irrational. Like yeah, it can be rational or irrational. So let's say you are still getting the discriminant and it is equal to a 0, which means right where you need to put the discriminant, now you're going to put a 0. So this part is now redundant, like it's no longer there, it's a 0. Therefore both of your roots, I mean it's just going to be one, just going to be one root. It's going to be 5/2, just 5/2, because it's plus or minus a 0. That's where you get only one root. And then you say that the nature of the roots, you will say the roots are equal. You're gonna just say the roots are equal. And another thing, if the determinant is a perfect square, like if the determinant is a perfect square is a number that if you get the square root of it, it's gonna give you a natural number. So if the determinant is a perfect square, therefore the nature of the roots is that the roots are real. First, the roots are real since it will be greater than 0, and they are rational. They are rational. Otherwise, if the determinant is a positive number but not a perfect square, the roots will be real. but they will be irrational. I hope that makes sense. Irrational. And just for a bit of context, let's say somebody asks, what is the nature of the root of this quadratic function right here? You already know that the discriminant of a function is equal to b squared minus 4ac, and you're just going to say the discriminant is equal to, you substitute the value of b by 1, because this 1 is the value of b in this case, minus 4 into what is the value of a. The value of a is also 1, and then what is the value of c is also 1. So this is going to give you, this will be 1 and this will be negative 4. So our discriminant will be equal to negative 3, and we have said this: if the discriminant is a negative number or less than 0, it means that the roots are non-existent, if you know what I mean. The roots are non-real. It has non-real roots. So the function will look something. So the function will look like this. So it won't cross the x-axis. I hope this video was useful. If you find it useful, leave a like, subscribe, and share it. Bye.